Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and before we dive into today's topic, I'd like to remind our listeners to rate our podcast on whatever platform you're tuning in from. Your feedback helps us improve and reach more developers like you.
And I'm Victor. We're currently in Season 1, Chapter 4, discussing decentralized storage systems. Today, we'll be exploring the concept of strong consistency.
That's right, Victor. But before we jump in, I have a quiz question for our listeners. In which type of system would you absolutely need strong consistency? A social media platform. B, a banking application. Or C, a content delivery network? Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a great question, Sheila. It really makes you think about the different requirements of various systems. I'm sure our listeners will have some interesting thoughts on this.
Indeed. Now let's start with the basics. Victor, could you explain what strong consistency means in the context of distributed systems?
Certainly, Sheila. Strong consistency is a property in distributed systems where all nodes in the system see the same data at the same time. In other words, once a write operation is completed, any subsequent read operation should return the updated value, regardless of which node in the system performs the read.
That sounds crucial for certain applications. But why is it so important? Can you give us an analogy to help understand it better?
Great question. Think of strong consistency like a group of friends sharing a single notebook. When one friend writes something in the notebook, everyone else immediately sees the same information. No matter who looks at the notebook or when they look at it, they all see the most up-to-date information.
That's a helpful analogy, thanks. Now, I've heard that strong consistency is related to something called ACID properties. Could you explain what that means?
Absolutely. ACID stands for atomicity, consistency, isolation, and durability. These are a set of properties that guarantee reliable processing of database transactions. Strong consistency is closely related to the C in ACID. It ensures that a transaction brings the database from one valid state to another, maintaining all predefined rules.
I see. So how do systems actually implement strong consistency? It sounds challenging in a distributed environment.
You're right, it is challenging. Implementing strong consistency typically involves consensus algorithms like Paxos or Raft. These algorithms ensure that all nodes agree on the order of operations and the current state of the system. It often requires synchronization mechanisms and can involve techniques like two-phase commit protocols.
Wow, that sounds complex. Are there any drawbacks to using strong consistency?
Indeed, there are. The main trade-off is between consistency and availability, as described by the CAP theorem. Strong consistency can lead to higher latency and reduced availability, especially in the face of network partitions. It's not always the best choice for every system.
That makes sense. So, when would you choose strong consistency over other models, like eventual consistency that we'll discuss later?
Great question. Strong consistency is crucial in systems where having the most up-to-date data is critical, such as financial systems, inventory management, or any application where data conflicts could lead to serious issues. However, for systems that can tolerate some delay in data propagation, like social media updates, eventual consistency might be more suitable.
I think I understand now. To summarize, strong consistency ensures all nodes see the same data simultaneously. It's implemented using consensus algorithms, and it's crucial for systems where data accuracy is paramount, despite potential trade-offs in performance and availability. Is that correct?
Exactly right, Sheila. You've captured the essence of strong consistency perfectly.
Thanks, Victor. Now, let's reveal the answer to our quiz question. The correct answer is B, a banking application. In financial systems, it's crucial to have strong consistency to prevent issues like double spending or incorrect balances.
Absolutely. Banking systems can't afford to have different nodes showing different account balances or transaction histories. It's a perfect example of where strong consistency is essential.
This has been a fascinating discussion on strong consistency. Before we wrap up, I'd like to remind our listeners to visit crashcasts.com and join our Discord community. Your support helps us continue creating these educational podcasts.
And if you're enjoying the show, consider supporting us on Patreon. Every bit helps us bring you more in-depth content on decentralized application development.
That's all for today's episode. Next time, we'll be diving into eventual consistency, so stay tuned.